Stay there. Okay. Sorry, I didn't mean to react that quick. Anybody get hurt by the sonic boom? y'all were right in the direct. Hearing okay? You're not stunned? Okay. Well, the rest of you probably just mild thunderclap. Okay. Now. It's just a fast flick of wrists. Okay, x plus 2 into this, right? And when you divide a number into another, you want to find a result, and your result is what you'd multiply by this to get this, right? Because if this divides into this many times, then this times this, it has to equal this, right? So what do we know has to go up here? Well, whatever goes up here when multiplied by x plus 2 has to give us x squared, doesn't it? So I'm going to put an x up here, because I know x times x squared is going to give me x times x is going to give me the x squared, right? Now, of course, x is also going to multiply this 2, isn't it? Okay? So from just this x, I know that I'm going to get an x plus 2, x squared plus 2x, right? So I know I've got this much of this. I've still got to find out how to get the rest of this. Okay, well, what's the rest of this? The rest of this is what I get when I subtract this from this. Okay? Now you can see this as just, here's what you do, here's what you do, here's what you do. You do it blindly, but if you understand what I just said, it makes sense, and you're less likely to screw it up. Okay? It's the difference between being able to follow an algorithm, which is good in itself, and understanding what's going on, which is even better. Okay? So you can get by with good. If you got better, I love it. Okay? So you're going to subtract this, right? Because it gives you whatever's left over after you've multiplied x by this. And what's left over is going to be just 3x. Okay? And that leaves 3x plus 6. Okay? And then I know that in order to get 3x when I multiply whatever's up here by this, it better be 3, because that's how I'm going to get 3x. It can't be 3x because it can't be anything with an x, because it'll give me an x squared, and I've already got the x squared that I need. I don't need another one. So I have 3 here. I multiply that by x plus 2. I get 3x plus 6. So 3 times x plus 2 gives this. Leaving 0, right? I never explained it like this. This just occurred to me when I was doing it. I think I'll try to explain why it is. Okay? I sure never heard an explanation. Okay? But it's a fairly simple explanation, so it's worth thinking about, but not worth having nightmares if you don't understand it. Okay? I expect some of you will understand it and some of you won't. That's okay as long as you can do it. Okay. Some of you could understand it but don't have time. I understand that too. As long as you do it, I'm happy. Okay? Want to make me ecstatic? Show me that you understand. Okay, do you understand that this is it and there's no remainder? Right? Can we check that? what I'm writing would be a good check, and it's going to be true. We want to write it in this order because it illuminates what's going on. Now this ought to be second nature to you. X plus 3 times x plus 2 is x times x plus 2, which is a whole lot like what we did to get this, right? And 3 times x plus 2 gives you this, right? That's our 3 times x plus 2. This equals x squared plus 2x, which I'll underline in yellow here and here. And then 3x plus 6 here. Okay? And then, of course, when we add that up, we get x squared plus 5x plus 6. Okay? And if you're multiplying this using anything but the distributive law, you're not likely to see the connection. Okay? Which is another reason I'm glad I am making you use the distributive law. Okay? Not some magic way of writing things down. Okay. So that's long division. Now there's another thing. If I do it quickly here, but x plus 2 into our x squared plus 5x plus 5. Okay? Well, that's going to give us x. We're going to get x squared plus 2x. It's going to leave us 3x plus 5. And we're going to multiply by 3. But now we're going to get 3x plus 6 as we did before. And the remainder is -1. Okay? We've divided by x minus -2, which is another way of writing x plus 2, right? And our remainder is p of -2. That's our old friend x squared plus 5x plus 5, the one we were using to try to find the zeros of, right? Anytime you divide a polynomial by x minus a number, your remainder is going to be p of that number. Okay? And I'll give you some polynomials to divide. Just, linear into quadratic, just a couple of steps, nothing difficult. Just make sure you subtract when you're supposed to subtract. And if you don't get what you should get, go back and see where you probably added where you should have subtracted. Okay?